All right, so let me share my screen. Okay, hello everyone, welcome back. Today we'll be going over mechanical engineering, a brief introduction, and then Kamya will share her screen for more information. So what exactly is mechanical engineering? The word itself comes from the word engineer, which is spelled like this, and also from the word ingenious. This term was created in the 19th century, which during this time, the steam engines were really important. They played a role in transportation, such as we have cars today, but back then they had steam engines, and also in the industry. And by the 20th century, it had become a broader industry, which is consisted of creating engines, mechanisms, tools, and systems. The field of mechanical engineering deals with many of physics concepts such as forces, materials, energy, fluids, motion, and design. Mechanical engineers usually use this knowledge in order to create products and solve real-world problems. Scientists normally emphasize the discovery of physical laws rather than just applying them in order to create new products, while engineers, they apply the knowledge of mathematics, science, and materials in order to create better technologies. So usually, if you study mechanical engineering in college, these are some of the things that you'll cover. So the core areas for mechanical engineering equals materials. So this is what you're working with. Statics and dynamics, fluid mechanics, usually these are physics concepts. Dynamics and heat transfer. This could be taught in chemistry or physics. Mechanical design, instrumentation and control, vibration, solid mechanics, uh, manufacturing and production, electrical power machines, and the other two below. And at the end of the session, we will also get an idea of what computer-aided engineering is. So now I'll stop sharing my screen and I'll let Kamya share hers. So you can share your screen.
Thank you, Anaya. I hope you can see my screen.
Yes, it's good. Yes.
Okay. Just a second. You guys can see my screen, right?
Yep, it's good.
Okay. So, hello everyone, I'm going to take the next part of the mechanical engineering workshop. So, first, let us know what is machining. Uh, Machining is a manufacturing process where we remove material, usually from a metal block, to shape it into a final desired part. This is done with very high precision, which is essential in industries like aerospace, automobile, and robotics. The three main machines used for machining is the lathe, the drilling machine, and the milling machine. So you can see an example here, starting from a solid metal block, which we carefully remove material and end up with a cylindrical shaft. This is the transformation, is what machining is all about. So now let's dive into the lathe, often called the mother of machines, because it is one of the oldest and most versatile tools. In a lathe, the workplace workplace spins and a stationary cutting tool removes material. And the key operations include facing, making it the end of the cylinder flat, and then goes to turning, which is reducing the diameter along its length, and then threading, which is creating screw threads. Okay, so here's the image which shows the label diagram of a lathe. Okay, you can spot the headstock, which holds the spindle, and the chuck that grips the part, and the tool post, which fits the cutting tool. The tailstock supports long part, uh, and the carriage, which moves the tool. So I'm going to show you a 3D animation so that you guys understand the real working of the lathe. Okay. Could you see the screen, the YouTube video?
Yes, we see the video. Mm.
Okay. It's just, that's the headstock. That's the carriage. The parts of the carriage. So this is the entire mechanism of it. So it uses a pulley system, as we can see. So it undergoes turning, facing, and turning. Okay. So let's go back to now. Uh, Next, look at uh, the drilling machine, which is also called a drill press. This machine is used for making holes in a material using rotating bits. And the key tips are always start by marking the center with a center punch for accuracy, and choose the right drill bit sized, speed and feed speed, and clear chips with a drill to avoid breaking the drill bit. You can see the label diagram of the drill press here. Um, it has a spindle that rotates the bit, and a table where the workpiece rests. This is a super common machine in workshops, and it is a key for all kind of fabrications. Let's see another animation of the working of the drill press. So sorry. Okay. Yeah. So that's the working of the drilling machine. This workplace, it keeps on moving. Okay. So moving on to the milling machine. Here the cutting tool rotates and the workpiece either stays still or moves. So we use milling for flat surfaces, slots, or gear cutting and complex shapes. Okay, the image shows a tool creating a flat surface with face milling. In the next slide, you will see other types of milling shapes too. So here the first one is made with the face milling cutter, and this is the grooved. This is the groove created with short milling, and this is the complex mill with a tool that moves 3D. So this you can see the complex shape around the. Okay, so going to the next slide. It's the Let us end this thing with the core concepts for precision and machining. So first is cutting speed, which is how fast the tool or the workpiece rotates, and the feed rate, which is how quickly the tool moves across the part, and the depth of the cut is how deep the tool cut goes in a press. Okay. So we also use cutting fluids to cool and lubricate the process. So let's look at this table over here. If you see the cutting speed, it's very low. Um, and so tools last longer, but the finish isn't great. It's If it is too high, the finish is improves, but the tools wear out quickly. Okay, so let's go to the feed rate, which is like if high speed rate is there, then it means that like the faster the machining with the rougher finish. And next, go to the depth of the cut, which is when we remove more material, but it generates like high heat and stress. Okay, so it tolerates is like very important in machining. Say you want a shaft to be exactly 20 mm. So you may need to keep it within 19.98 to 20.02 mm. That's how tight things have to be. So, and lastly, a surface finish makes it makes I mean sorry surface finish matters because if it's too rough, the part may not fit well or might wear out quickly. So machinists aim for a finish that's both smooth and precise. So that's a quick tour of machining and precision tools. I hope it helps you appreciate the science and skill behind shaping metals into useful engineered parts. Thanks a lot.
Yes, great job. Okay, so now we'll go over a little bit of engineering designing to end off the session. So, what exactly is engineering designing? Is my screen sharing? Can someone confirm?
Yes.
Okay, perfect. So, engineering designing is the process where these engineers generate, evaluate, and specify devices, systems, and processes in order to create what they want through constraints. So, for example, if I want to create something with certain rules, then I will have to apply those constraints when keeping in mind the design. So, here are a few examples. Um, these would be in real time, so gears and other tools. And then for these tools, we'll have drawings, 2D drawings, in order for them to be replicated and to be seen from the internal view. So I'll have a brief example here. Can you guys see my Fusion screen or is it still showing my tab? Oh, okay, I'll reshare my screen. One second. So here's an example of a tool. So you can see it here, it's in 3D. You have different components. However, if I wanted to recreate it, how would I know what the inside looks like, the exact measurements, and other aspects? That's when drawings come in hand. So for that exact tool, we have this drawing over here. So we have this one component, And this is the top view, which we can see the 2D view from the very top, and it's labeled as 1. And then we can see the second drawing, which is the 2D view of the left-hand side, which is labeled as 2. So this is how engineers can generate drawings through computer-aided design or CAD. And this is just one example. This can also be generated very easily nowadays. Before you would have to do it manually. But now if you just click File and New Drawing, and then from the design itself, you can choose whether you want it to be automatic or manual. And then based off of this, you can choose your own templates, the width and height, and other aspects that you would like to do it. So if I click automatic, then it should generate me a drawing based off of this tool that I have over here, pretty similar to the other example I had over here. So we'll wait a few seconds. It's gonna load. But yeah, and this is a really great platform for creating 3D models, whether you want to 3D print it or you just want to design something before actually creating it hands-on. So this would be like oh, so you get like a little notification here and it lets you know how it's going. But overall, the drawing would end up looking like this. And then it's really important to make sure whether it's measured in inches, like the metric system or the inches. So there are different symbols here. We can see that these circles with the little dash between it, that's for the radius of the any circles found on the design. And then we also have these are for the angles, the radius of the circle, which creates the angle. And okay, I'm not sure if the drawing will generate right now, but it will look just like this. So that is a little example of what exactly engineering designing may have. And this is something that you will learn in college if you want to become a mechanical engineer, as design and communication is very important. As an engineer, it is a core fundamental skill. So, yeah, I hope you all enjoyed this session. We will be having a part two, I'm sure, in the next few days, and look forward to more. Kamya, do you have any finishing thoughts?
Yeah, that's all. Hope to see one more time. Yeah.
Yeah. Okay. Thank you so much. Bye,
Yeah.
guys.